All right, so we're going to pick it up now where we left off with VBA. We're actually going to use the VBA editor, and we're going to see how the VBA language works. So if you recall, we just started this the other day. And so what we need to do is, of course, make sure that you have in your Excel spreadsheet the developer tab installed. It's technically, I mean, it's already part of Excel, but you have to go through the trouble of asking Excel to put this up on the ribbon. So if you haven't done so already, at least on a PC, what you have to do is go to options. And there's a lot going on here. I mean, but what we're after here is, I mean, you really could change everything in Excel. And later on, I'll show you some more of these. But um, for this one, what you're doing is you're not adding like an add-in program as such. You're just telling it to turn on part of the ribbon. Now, here's the strange thing. I mean, when you first get Excel, the ribbon has everything checked except the developer. I don't know why they would do that. Maybe they're afraid people will be scared when they see it. But anyway, all you have to do is click on the box for developer. And just like magic, it appears on your ribbon. And so once you have that, you can now go ahead and you can execute code or you can run macros. There's other things you can do too, of course. But we're not, this is not a VBA course. What we're interested in is being able to write simple programs that implement our derivatives pricing models and other applications as well. So if you noticed, when you look here, there's already quite a few example files here. That I've labeled them VBA example 1 through 17. So we want to get a feel for how the language works before we tackle any assignments. So there's VBA is a fairly old language. It's been around since the late 70s, but it's still being used because it's very straightforward for the most part. It's not nearly as powerful as newer languages like, let's say, Python or MATLAB, but it does the job. And so a lot of Wall Street analysts are still using it, even to this day, to at least develop models, test their ideas, and see how things work. And then once it's done, of course, this code has to be converted into something much faster for use on the, let's say, the trading desk. And that's where the programmers get involved. They can take your VBA code and turn it into something very quick, like C++ or whatever. It's getting to the point where I'm not sure myself what the new languages are. Although I did study computer science undergraduate, it was a very long time ago. But anyway, the VBA stays useful because it was structured to be very English-like. The statements are very readable, let's say, and but there are some quirky things about it that we have to know. It's the trade-off is that because it's fairly straightforward and English-like, it's meant to be as user-friendly as possible. But that means that we basically have to do a lot of things ourselves. And there's a lot of assumptions that we have to watch out for. You assume certain things are going to be done for you, and maybe that's not always true. So we'll start at the beginning. We'll look at some basic examples, and we'll see how they work. We'll start to get a feel for how this language works. So we could, for example, no, let's not start with that one. Um, let's do this. I want to start with the ones that are just straight ahead math. Okay. So, and by the way, I did mention last time we have all these different windows we can use to debug our program. If it doesn't work correctly, we have to figure out how to fix it. And this is one of the areas where VBA is actually quite weak. Its debugging capabilities are fairly limited. It doesn't always give you a good sense of what's going on. So at the very least, though, we can at least set up these windows to keep an eye on what our variables are doing so we can look for possible problems. So we go to the so-called code window. Now, this is example number 3. And we've already gone through this, but just as a quick reminder, first we start by mentioning that all the blue words are keywords, they're called, and these are reserved for specific purposes in VBA. You may not use those for variable names or for any other purpose. But it's helping you out by putting it in blue so you know that that is a keyword. To a certain degree, by the way, here's one of the things it can do. You don't see this everywhere. it can try to help you fix typos. You'll notice, I mean, if you type something or if you miss the capitalization, as far as I can tell, the capitalization is not that important with at least with the keywords. If you try to type one of these words, let's say if I type sub like this, uh, okay, well, that red means you've really goofed it up. But sometimes if all you've done is made a typo, it can actually fix it for you. So, but we don't want to push our luck either. But anyway, so here's what you typically do with a typical program. We start with the keyword sub. Now, there's only two types of programs we're going to run. Sub is short for subroutine. This is also known as a macro, which means you can execute it from here. Okay, and in fact, we did this the other day. These are little programs that can be executed just by clicking on the button. The other alternative to a macro is what's called a function. And now the functions behave very much like the functions that are built into Excel rather. So what's different there, like for example, you say equals the square root of 8 or something like that. When you write your own function, you're creating something where you have to specify to the function what information it needs to do its job. All right, in other words, for something like this, you're going to have to tell it that it needs to read in a single non-negative number. And if by the way, you ideally you want to set it up so that if somebody gives it the wrong number, it'll provide an error message. But basically, you have to specify what information comes into it and what should come out of it. So that you can't do with a button. The way you execute a function in Excel, whether you've written it or it's part of Excel, is that you put equals and then the name of the function. And then now here you notice it's helping us by reminding us that we need to put in a single number. These little ribbons will tell us what information needs to go into this function. Now, if that's not enough, we have this other little help insert function button where it's actually going to come back and tell you what exactly needs to go into the function. And it has a lot of explanatory details as well. This is very helpful because often a function needs multiple values to be read into it. And it's possible or easy to forget the correct order, or if there's any restrictions on those values. For example, if those numbers are restricted to being integers, you have to make sure that you write that into the function and that it's clear to the user that you must only use integers. Okay, or for something like this, clearly whatever Excel has done here, they've written it so that if I try to take the square root, for example, of -8, it'll come back with an error message. Okay, now it's not a helpful, very helpful error message. This in Excel means something's not right. Num, okay, it's not that helpful. In newer language like Python, maybe the debuggers are a little bit better, but here, at least it's telling you that there's a problem. Okay, and then maybe you can investigate and figure out what it is. When you write your own code, you ideally would like to do something similar. At least find some message to send to the user if there's an input problem. But you can't just run this square root with a little macro button because it is a function. And because it's a function, it means it's restricted to giving you one output only. So the square root, I read in a number, I pop out another number. With a function, with a macro rather, the advantage of the macros is that it can produce as many outputs as you need. Okay, you could, for example, have a macro that produces 10 different variables. It doesn't make any difference with a macro, okay, or subroutine. So something like this, I could ask it to print out many different variables. For example, what you see here, what I've got is the price of gas, the number of gallons, and the total spent. So there's 3 outputs, which only can be done with a subroutine or macro, okay, not with a function. Now, on the other hand, functions can accept as many values as they need. There's no restrictions on how many values go into the function, but the restriction is on one coming out of it. Okay, so this is what we have to choose from. So very complicated scenarios are often executed with macros. Simple cases are often done with functions. Like, for example, if I decide that, it's it's sad that Excel doesn't have its own cube root function. I can just write one of my own, and from then on, it becomes available to me as if it were a regular Excel function. Okay, it doesn't make a distinction between your functions and the ones that are built into Excel. Okay, now, with all that being said, recall that we defined these constants last time. Price of gas is 225, number of gallons is 20. Now, the only unfortunate thing here is that we're stuck with those numbers. So what we will see later on is that there are ways that we can give it a location to find this information, and then we can put any numbers we want in there. We can change it to our heart's content. So, but here we're stuck with two constants. So the problem will automatically give us the result of multiplying for total spent, 225 for the price of gas and 20 gallons. So no matter how many times I run this macro, I'm going to get the same output. Okay, and because it says debug print, it goes into one of our special windows rather than the spreadsheet. So we only did that so you can see how this works. Okay, normally we'll put all of our output on the spreadsheet. All right, so what else do we have waiting for us here? Yes, the immediate window is where these results go if you tell it you want debug print. All right, now let's try a new example. This, by the way, this is Object Browser. This gives you a sense of all the functions that are available to you. It's a huge list if you scroll down through it. It's a lot, yes. So now what we're going to do is go on to the second part of this discussion, elements of the VBA language, where we start to learn how VBA itself actually works. So what kinds of objects can we encounter in a VBA program? Well, most of these are pretty self-explanatory. We have variables, of course, X, Y, whatever, constants, which are numbers that never change, procedures. Now, a procedure is a small block of code that is designed to execute create one output. The interesting thing about VBA is that you can have within the same program many different procedures which are designed to do specific tasks. That, in order to keep the program manageable, we often break it up into procedures so that we have all these different procedures doing individual tasks, and then the program just sort of ties them all together. Okay. Now, arrays are just another word for vectors or matrices, because arrays can be one or two dimensions. So if our array is one dimensional, make a note of this. Oh, hold on. To turn that on. If the array that we're defining only has one dimension, okay. Looks like my tablet is refusing to work at the moment. That's nothing new. Well, what a shocker. Yeah, I mean, the idea of the tablet is really amazing, but I mean, the mouse works. It just works. The tablet, it can be really finicky. And I'm really having a lot of trouble with it lately. I actually have two of them. And right about now, neither one of them is working. So in other words, it's literally stopping me from writing. Oh, what a shocker. Um, oh, maybe it'll, oh my God, I got it to wake up. Okay. So here's what I wanted to say after all that. A one-dimensional array in VBA is what we know in math as a vector. Now, it doesn't have, we know that in math, a vector can be either a row vector or a column vector. We don't need to specify that with an array in Excel, a VBA rather. A vector is a vector. It's just a string of numbers. Um, we don't have to specify row or column. It doesn't really matter because the calculations will be done the same way anyway. But when we have a two-dimensional array, that changes everything because a two-dimensional array, as you know, is a matrix. And then we have to specify everything, every detail. We have to specify the number of rows. We have to specify the number of columns. And of course, the data that goes into the matrix. Now, VBA has a surprisingly sophisticated number of matrix operations built into it, as does Excel. It can multiply them, it can invert them, it can transpose them. I'm not sure if it can do anything else, but those are the things that we'll definitely need it to be able to do. Okay, now here's an interesting twist. It can have three-dimensional or higher dimensional arrays. I don't know when you would ever use that, but it can be done. And now here's another one of the really interesting features of this, of these arrays. An array, of course, has an index. Let's say, for example, you have a vector that contains, I don't know, prices. You've visited a bunch of gas stations and you wrote down, how much are they charging per gallon? Let's say 4 gas stations in your neighborhood. Now, of course, we know this as a 4x1 column vector, but Excel, a VBA rather, has to have some way of keeping track of these elements. So you can think of this as, for example, let's say this is gas prices. And I've defined my vector in, or my array in VBA as G. If I want to, I could define this as G of 1, G of 2, G of 3, and G of 4. But if I prefer, I can do something like this. Now, here's where it gets really interesting. If there's some really good reason for this, you can actually give it any indices that you want. In other words, you can literally have a negative index in VBA. Now, this is a very powerful feature. As you'll see when we get to that part of the course, we're going to need this capability. And believe it or not, some of the higher end programming languages like MATLAB don't even have this capability. In fact, many years ago, I actually was, when I figured this out, at the time, I still was leasing a copy of MATLAB, so I was entitled to consumer or customer support. And so I actually wrote them a letter, or actually, I guess it was an email. It was such a long time ago, it could have been a letter. But I said, hey, how come you don't have negative indices like VBA? And they wrote back and they said, we're working on it, or some nonsense like that. And of course they weren't, because they've never changed it. So this is one of the things that really makes VBA unique. This is something you don't see in most other languages. The idea that you can have indices of any value you want. So anyway, I thought we'll discuss this again when we get to that point, but I thought you'd find that interesting. Now, VBA functions. Now, here's one of the wacky things about VBA. And I don't even know how this could have happened, but what's unusual about VBA is that most of the functions you'll use are actually borrowed from Excel. Okay, so VBA is attached to Excel. And if you want to go on the internet, you can look at a model of how this whole thing is set up. But the bottom line is most of the functions we'll be using are actually Excel functions. But for some reason, VBA has its own set of functions too. And in some cases, they overlap with each other. For example, they both have a square root function. And it turns out that in those cases, the spelling is different. For example, with square root, um, the Excel version is SQRT, and the VBA version is SQR. So the rule is that anytime there is a VBA function, you must use that version of it. If not, you can go ahead and use Excel's function. So if I wrote in my VBA code SQRT, it would not understand what I mean. It would say, what are you talking about? Square. You're supposed to spell it SQR. So it's kind of a bizarre situation. Luckily, there aren't that many of these. For example, log, there's random, there's a few others that we'll encounter. So we just have to be careful. Anytime there exists a VBA function, you must use that version of it. Now, if you want to explain to me why this happened, I would like to hear it, because the only thing I can think was that VBA was probably invented or developed by a separate group of programmers from Excel, and then they smushed it all together, and then they realized at some point, uh-oh, have a conflict here. So this is what ended up happening. Then we have, of course, our normal mathematical operators. They're the same ones you see in Excel. Okay. The only ones that might seem a little strange compared to what you normally see in everyday usage, VBA and Excel use the caret symbol for exponentiation. That's the only one that really is different. The TI-84 series calculators use this too. It's not that unusual, but some mathematical programming languages use double asterisks for this, but here we're using exponentiation, the caret symbol. Which, by the way, if you never knew this, symbol is spelled caret. And then we have our logical operators, which means things like and, or, not. And then we have text functions, which can operate directly on, let's say, strings of letters. They can combine them, they can take them apart, they can search through them. We won't be using those very often. Okay, so anyway, let's just take a look at these one at a time. So variables can be used to store information within a program. Now, in other words, if I am writing a program that calculates, let's say, the humidity based on today's temperature or something like that, the variables are the ones that will be read into the program, and then it does its work. Now, you would think that there aren't that many different kinds of variables, but in Excel, there's actually a very large number of them. Now, you won't probably be using most of these. We have a single byte. Now, this is going back to the origins of computer science. A byte is a single unit of storage. It's enough space to store a letter, a character, a number, a symbol, whatever the case may be. Every one of those objects you see in your screen, like a 3 or an asterisk or 9 or n, is stored in a single byte. Okay. Now each byte has individual bits. Depending on your computer, the number of bits in the byte can go up as high as 64. So a single byte of information, let's say you have a byte that contains the letter A. This is expressed in the computer's memory, not as an A, but as a bit consisting of some binary, a base 2 number. And the string of numbers will depend on how many bits your computer is using. It's going to be either 8, 16, 32, or 64. So this isn't right. So the A could be represented as, let's say, 8 of these. I just got one too many. I don't happen to know off the top of my head how A is represented. Oops. Okay, that's better. Okay, but this is how the computer stores information. These zeros and ones actually refer to off and on, where electricity is either flowing through or it's not, or something to that effect. I'm not, a hardware expert here, but so these individual characters, numbers, letters, et cetera, are all stored in this not hexadecimal, base 2 code. And this is how the computer reads all this information. So these are called bits. So in this computer, this 8-bit computer, there are 8 bits in each byte. A more modern computer will probably have 64. Okay, the one you're using right now probably has 64 bits. So that means that each byte consists of 64 bits, and each of these bits is either a 1 or a 0. Okay, and that's how it sees an A. It doesn't know what A means. It knows this. This is what it knows. Okay, now going back to ancient history, you can technically store your information in a byte or as a byte. As far as I know, that can potentially save some memory, but at this point in time, memory is not such a big problem as it was back in the day. In the early days of computers, memory was very, very expensive. So there's a lot of focus placed on efficiency, which we don't have to worry about so much anymore. Now, we know what an integer is, of course, but there's a different kind of long integer. Now, this is the distinction here is in this chart. So to 0 to 255, 256, hold on. Okay, here we go. So in other words, 256 is 2 to the 8th power. So if you have a string of 8 digits, they can range from anywhere from all 8 zeros to 1, 1, 1, 1, 1. So that means there are 256 different possible values ranging from 0 to 255. That's why it's set up this way. The integer, now this has to do again with the way back in the day when storage was limited, a single integer or just plain integer only requires 2 bytes of storage, but then you're restricted to numbers between 32,768 and 32,767. If you're willing to put up with 4 bytes, you can extend the range of values. Now, keep in mind, now we're obsessing over bytes here. Remember, now this language was developed in the 70s. I mean, at this point in time, I mean, your Apple Watch probably has more storage in it than a mainframe computer had in the 60s or 70s. So we don't really have to worry about this. I mean, a typical laptop at this point in time has 1 or 2 terabytes. A terabyte is 1 trillion bytes, by the way. So I don't think we have to we don't have to worry about the difference between 2 and 4 bytes. We're not going to run out of space. Okay. Then we have single precision, which means you have a decimal point. Okay, this is the range of possibilities. That only takes up 4 bytes, and then double, negative, double, positive. It can give you more, but they're restricted to that sign. We also have currency, which is meant to represent dollars. So most of the time, you're probably going to wind up using single precision, maybe double. What else do we have here? Boolean. Now, this is an interesting one. With Boolean variables, there's only 2 possible states, true or false. And true is represented with a 1 and false with a 0. So in other words, imagine the variable that represents whether or not you are retired. it's a yes or no question. So it may make sense to define that as a Boolean variable. And then it's easy to keep track of it. Okay, and then you can do mathematical operations on it if you need to. Then we have date, which is pretty self-explanatory. String just means letters or symbols only. Object, that's a much more complex idea. We'll get to that later on. Um, Now, variant is an interesting variable type. If you're not sure what kind of variable you have, you're not sure if it's an integer or let's say, or maybe even has letters in it. Variant type means anything goes basically, can store any information, but it also uses up a lot more memory. It might go up to 16 bytes, let's say. You might use this if you're not clear what this variable is all about. And then you can literally create your own variable. This is pretty surprising considering how old this language is. I can create anything I want. If I know what I'm doing, I can create a variable called, let's say, phone book. And phone book is an array that contains a name and a telephone number. And once I define that, Excel or VBA says, oh, I know what you're talking about. And you can do whatever you want. All right. So what distinguishes these? How much storage does it require, and what values can it be assigned to it? Okay. All right. So here I've got more discussion about these variables. It can do scientific notation. Oh, here we go. We've got some more discussion here. So Boolean is only 2 bytes. It's either yes or no, true or false. Date, obviously, we know what that is. What's interesting about dates in Excel is that they're stored in such a way that whether you notice it or not, if you put a date into Excel, it's actually storing it as a number. And that number represents how many days have elapsed since January 1st, 1900. Okay, unless it's a Mac. I think it's slightly different on a Mac for some reason. So it's actually a number. In fact, if you have Excel open, you want to check this out, you put today's date. And then I say, oh, whoops, I meant for you to show me the number. That means it's been 45,448 days since January 1st, 1900. Wow. That's what it means. Okay. And the advantage of that is that you can do things like this. Let's say I want to know how much time has elapsed. Let's say for some reason, I want to know how long it'll be until Christmas. Oops. I can say, let's say I'm worried that I haven't started my shopping soon enough. So I can do the difference between the two. And I can say, oh, good. I have 204 days left. I guess I have plenty of time. So yes, so there are a lot of advantages to having this actually be treated as a number. String means letters and characters and that type of thing. Object, again, we'll have to save this discussion for another time. Variant can mean literally anything, and then user defined can be anything that we can think of. Boolean, yes or no. The dates, as we just discussed. There's a million different formats you can use. A string. Oh, I forgot to mention this. When you do enter a string into Excel, it has to have quotes surrounding it. Okay, it has no other way of knowing what you're doing. Like John Smith. Let's say you have a variable called name and you want to assign it a name. This is what you would have to do. And this way it can have blanks, by the way. Okay, you can literally put anything in here because it's just saying, okay, what are the strings? And if you put numbers in there, you can't do math on them because it doesn't treat them as numbers. And then your strings can have a fixed length. You can specify that, let's say it's a social security number, it has to have a certain number of digits. Um, and because even though it's a number, your social security number isn't something you would do mathematical operations on. And you would never have the concept of, let's say, one number is greater than the other. It's not a meaningful idea. So all you need to know is the actual numbers and the dashes. So that would be an ideal candidate for putting it into a fixed length string, because that way, if it's off, you know something's wrong. Or your birthday, for example. But for names, because they can be any length, um, in fact, I actually knew somebody in college who was, his name was Vuvo, and so he only had 4 letters in his entire name. But I've also have friends from India where the last name alone is like 20 letters. So um, you don't know what you're going to run into with names. So you can have variable length strings in there. Now, an object can be, all right, I guess we can discuss this now. These are the kinds of things we're not going to use. You can literally create an object variable to be an entire row or a column or an entire worksheet or workbook. Um, it's a very complex thing. We're not going to really run into this. If you want to do this, though, you need to use the set keyword. Okay. And then variant is the one that you can assign anything to it, but of course it takes up more space. Okay. Um, Now, when you're writing your code, VBA needs to know what each variable is going, what type each variable is going to be. If you don't specify that, it will assume you mean variant. So it won't blow up the program if you forget to tell it, let's say that X is supposed to be an integer, but it does mean that you'll be needlessly using up extra storage space. Again, in this point in time, it's not such a big deal, but it you still, it's helpful if you tell it right up front what each one is supposed to be. Let's say you've got a variable like the number of people who live in a household. And of course, it has to be an integer. If you specify that this variable is an integer and somebody tries to provide information that is not an integer, then that will trigger an error message. And that's what you want, because in other words, if you're going to write a program that requires inputs from people, ideally you want it to complain if something's not right. And so by saying, no, this variable has to be an integer, and somebody gives it 3.6, then it will at least provide an error message. Whereas if you don't do that, if you treat it as a variant variable and somebody types in 3.6, the program has no way of knowing. And so it will not trigger an error message. Okay, so you want ideally to specify them all up front. There's different ways of doing this, by the way. We'll see how that goes. But by the way, I do want to mention here, one of the good things about VBA, it's an incredibly flexible language compared to the other ones. There's a lot of information that should be specified at the beginning of a program. In VBA, often you can wait until later in the program when you have more details about your data. And you can tell it much later in the program what you want these variables to be than you might in another language. Okay, you might say, well, listen, I'm not sure if this number is an integer or not. So I'll tell you what, read in some numbers and then let's see what happens. It's okay with that. It's very, very, very flexible. And the keyword dim is designed to let you do exactly that. In other words, the word dim says, I want you to make this an integer. And you would use the word dim. Like here, for example, dim customers is an integer. The number of customers clearly has to be an integer. Dim price is a currency. Dim length is single precision. So again, these are designed to make the program more consistent, I guess, and to also trigger error messages if there's a problem. Oh, here's some more. Mail is Boolean, name is string, birthday is date. Now here, we didn't specify it, and that means it's going to interpret that as a variant. Unless, now here's the thing, you can change your mind within the same program. Like further on down, you say, I think maybe we should let birthday be numerical or something like that. You can change it. Okay. It's actually possible to change it. All right. Now, this is an example. I mentioned this earlier. You can have your own user defined variable. Here's a case. You created your own variable called personal information. Now, imagine you're working in a company where all the customer records have this form. And instead of sitting there typing all day, you want to be able to automate it. So you can create a variable called personal information where it knows automatically that it will consist of a name, which is a string, a first and last name is a string, a date of birth as a date, and marital status as a string. See, now marital status would be tricky to make into a Boolean because there can be different marital statuses. It's not like all there is to choose from is single and married. There can also be, for example, divorced or separated or married more than once. So that one would become a string. So anyway, in this way, it would know if something is left out or the type is wrong, it would know enough to provide an error message. Now, like I said, you don't have to do this. This is completely optional, but it's good practice, good programming practice. Now, on the other hand, suppose that you don't really trust yourself to do this, to make this decision, or you want to make sure that you don't forget to do this. You can type in this command option explicit. And what that means is you're telling VBA, you must define each variable, whether you like it or not. Why would you do this? Well, because suppose your intention is to define each variable and you leave one out by mistake. This way, the program will stop running and say, listen, you forgot to specify that, let's say, time is a numerical value or whatever. So it's there to help you avoid mistakes. Okay, it has a lot of these functions built into it. Like I said, the programming language was meant to be as user-friendly as possible. But it's like it has these little features where you can sort of force yourself to do things that are good programming practice. Now, the functions and subroutines, actually, the functions, sorry, themselves, you can also tell Excel or VBA, do you want the output of a function to have a certain type? So in other words, if let's say you're trying to calculate the square root of 9, and you want to make sure it knows that the output should be a single precision variable, then you will need to tell it that. Or if, let's say, you want to make sure that it doesn't actually print out a letter or something like that, then you can say, listen, this function is designed to produce a single integer, single precision variable. Make sure that that happens. Otherwise, it'll stop and produce an error message. So it's not just the variables that can be defined, the functions too. And not only that, but the inputs that go into a function can be defined in the same way. For example, what if I want to make sure that in my sales tax function, the retail price and the sales tax rate are single precision variables? That if somebody accidentally types in a letter or something like that, it's going to cause an error message. Okay. The individual variables that you use in your program, same thing. For example, dim age as integer, et cetera, et cetera. That way we know that if, let's say for some reason we only want integers for our ages, we can make sure that whatever the program does, it produces an integer. Okay, so what we're doing here is making sure all the variables that we're using, whether they're inputs or outputs, are going to have the correct type. All right. Oh, now here's a tricky thing about a language like this. The equals symbol does not mean what you think it does. If you just do math and you've never written a line of code in your life, you might think that this refers to equals. This means is assigned to. Age equals 50 means we're assigning the value 50 to age, the variable age. Price is 156. The actual equal, like if you're trying to test a condition, like if x equals 3, do the following. In VBA, you're going to use double equals to represent true equality. This equal by itself means we're assigning it. Okay. Now, constants. Sometimes we have constants in our program that are not supposed to change. We don't want them to accidentally change. So we have a keyword called const to make sure that that doesn't happen. For example, the value of pi, the freezing point of water, or the Social Security retirement age, for example. We don't want in our code to accidentally change the value of a variable, which has been defined as a constant. And this way we can stop that from happening. Okay, like, what if I accidentally typed a line of code in my program, pi equals 1 or some nonsense like that? Well, then all my calculations will be wrong from then on. Oh my God. So, by the way, when we're done with this, we're going to get back to our examples. I think this is fine as far as it goes, and we can refer to this as much as we want, but I think you'll learn more from the examples than anything else. Here's a good one. Const sales. We're going to see this in one of the examples, by the way. Sales tax rate as single equals 0.08. Single precision. Let's go back to our chart for a second. Remind ourselves how many digits there are with single precision. Oh, here it is. Okay. So that's that. Oh, by the way, I forgot to point this out to you. E38. This is scientific notation. It means negative 3.4 times 10 to the 38th power. And on the upside or the positive side, it can go as high as 1.4 times 10 to the 45th power. Those are some big numbers. If you need to go outside that range, you're looking at some like gigantic numbers. So that's why I said most of the time we'll probably end up defining our variables as single precision or else integers, or maybe occasionally we'll have a letter or something. So single, that covers a lot of possibilities. Okay. But if you're like, look at these numbers, how is this even possible? I can't imagine any variable that could go that high, but anyway, so single precision covers a lot of territory. And so we're defining this as single. And that's, so that means it can be a decimal like this. And this means that no matter what I do in my program, I can't accidentally change this. It's going to stay at 8 throughout the whole program. Now, when you name variables or functions or subroutines in VBA, there are certain conventions we have to follow. First, we always start with a letter. The name cannot contain a space or any of the following characters. And it can't go past 255 characters. That's a restriction from the fact that it's such an old language. And of course, you must not use the keywords. Okay. So, but luckily for us, it does highlight the keywords in blue. So if you aren't sure if something is a keyword, just type it into your code and see if it turns blue or not. So procedures are a block of code for specific tasks, as I mentioned before, and there's the two basic types, functions and subroutines, which are also known as macros. And a function is designed to generate a single output. You can send all the information you want to it, but it's only going to ultimately produce one number. Although it doesn't have to be a number, by the way. You can have a string function, which takes, let's say, for example, you are reading in data from a customer database, and you do not, on your whatever report you're producing, you don't want anyone's middle names to appear. What you can do is write a function that strips out the middle name and then produces just the first and last name. Or let's say the name is like John C. Smith and you wanted to say Smith, comma, John. Then the output of your function would be a string variable. Okay. It doesn't have to be a number, although it usually is. And now if you notice, in order to use a function, you have to tell it what data it needs. For example, the sales tax program, which we'll be seeing in a few minutes, you need to tell it the retail price of whatever you're buying and the sales tax rate. Now, the way you've written this program, this tells me that if I get these two backwards, I'm going to get the wrong results. So in other words, it's very important that you know, and the user knows, that when you enter this information, it needs to be told the retail price first and then the sales tax rate. Okay. If you get them backwards, or if you leave one out, you're just gonna, if you get them backwards, it'll do the calculations and give you the wrong number and you won't even know what the problem is. If you leave one out, of course, it'll stop functioning. It'll give you an error message. Or if you try to give it three variables, for example. And then now this takes place automatically. As soon as you type in the keyword function, it will at the end give you this end function command because it needs to be there. So here it is. It's so simple. Look at this program. This is a function. It's called sales tax. And we open parentheses and we're asking the user for the retail price followed by the sales tax rate. Now, if you want to make sure that these are not the wrong type, you could optionally type retail price as single, sales tax rate as single. And if you want to make sure that the function produces a numerical output, right here, you would put as single to make sure the output is a single precision variable. None of that happened here, okay? But we could have, if you wanted to be very, very precise. In fact, let's do that right now. All right, so just in case you're concerned that somebody's going to give you the wrong information or something will go wrong in the program. What you could do okay? And then these are keywords, so they would turn into blue. So you would notice it right away. And then you notice what it's saying to you here. Sales tax is equal to the retail price times the sales tax rate. Now, you have to make sure that whatever you call this function gets assigned the result somewhere in the program. Okay, in other words, if I make a typo in the sales tax here, I'm not going to get my answer. The program is expecting to find an assignment of a number to sales tax, and that will be returned to the spreadsheet. And then now this end function would have been put in there automatically by VBA. It has to be there. So it knows where the starting point is and the final point is. And so when you start doing this yourself, you'll say, hey, that was interesting. It went ahead and put this in for me. So you see, it's trying to anticipate what you're doing. In fact, why don't we go over here and find code number, example number 4. Whoops. There it is. Now, what I'm going to do is edit this. Oh, I think I made a typo here. I don't think, I'll tell you what, when it comes to the keywords, I don't think that it cares about the case. For your own variables, yes, but something like that, I don't think it cares. Oh, see, now maybe I was wrong about that because if you notice, once I made it capital, it suddenly say, oh, wait a minute, those are keywords. Okay. So I guess I shouldn't have said that. I was under the impression that it's not case sensitive, but I guess we should never assume that. And then here, again, if you want, and this is purely optional, this way there's no problem. There's no possibility anyone will send to this program the wrong information. Or if they do, you'll get an error message. Okay. Okay. By the way, here's a little helpful hint too. We haven't gotten to this yet, but what if you want to put information in here to help remind you what you're doing? What you could do is use a comment. If you put an apostrophe, you notice the whole thing turns green. And what VBA is telling you is that it's not reading any of that and because it knows that it's a comment. This is a message from yourself to yourself saying, the next time you run this program, don't forget what this is supposed to be doing. Or, then this, you'll see this can be an incredibly important feature because, there's a lot of information in here. You might forget what you were trying to do. And and not only that, but you can add it at the end of the line here. Like once this, oh yeah. And as soon as it gets to that point, it skips to the next line. It says, all right, whatever, I don't care. If you need to put comments in here, that's fine. It's not none of my business. So you can put those inside here. I don't think you can put it on the outside, but anywhere inside you can put your comments. And I think it's a good programming practice because that way you won't forget when you look at this program down the road what you were trying to do or what the variables represent or any other important information that you might need. And now, by the way, just to get some practice, why don't we try this? I'm going to say, well, oh, what happened? Sales. Now, if you notice, it's in the list. The fact that it's not all caps tells me that this is a user-defined function. So instead of typing it, I can double click, which will help me avoid typing errors. Now, the only unfortunate thing is that it doesn't have a ribbon. I have to remember myself what information to put into it. So if I say, well, the retail price, I bought something worth $100 and the sales tax rate in my state is 8%, it'll come back and say, oh, well, then you paid $8 worth of sales tax. Ah. But if I do something wrong, let's see how it reacts. If I type 100 and then C. See, now it's really upset. See, the thing is, because it's user defined, it doesn't really know what to do now. But at least it's drawing your attention to the fact that there's a problem. Okay. Saying what's going on here. It doesn't know what the problem is because it's not an Excel function. Now, here's a very clever way of using this. Suppose that I have a lot of these. Like, well, I made a lot of purchases and I want to do them all at once. So if, let's say, wait. What I can do is this. Instead of referring to the numbers, I can use cell references. And you might say, well, what's the big deal? But the nice thing about this is if I want to do this for every one of these cases, for every one of these purchases, I don't have to type it all 5 times or 6 times. I can just drag it across. Uh, yeah, like that. Because it's now here saying B1 and B2. But actually, I can show them all to you at once. So because it's using cell references, I can repeat this calculation as many times as I want without retyping it. Okay. Now, what I can also do, as we'll see later on with more complex cases, I can create what's called a loop in the body of this program and do it over and over again within the body of the program. But that requires a subroutine. Okay. But anyway, so there's a lot of possibilities here. A lot. And so, yes, calling a function, what you have to do is actually type the name of the function and provide the inputs that you need. Oh, and by the way, there's another advantage of this. What if I discover that I made a typo? Well, let's say this one was actually 175. Watch what happens. Oh, it automatically updates itself. Isn't that nice? Okay. So then we remember that you also have subroutines, which are called macros. Now, a macro is a small self-contained program which doesn't require any inputs, or if it does, you have to tell it where to find them. And but these are not executed as the functions are. We go to up here on the developer tab and we ask it to run that macro. Just click it on and it runs. Most likely, you'll be using subroutines or macros for most of your programs. Interestingly enough, though, and we'll get to this later on, within a subroutine, you can add functions. Okay, in other words, if I can have a big, broad subroutine that contains many individual functions and call on them individually to do different tasks, and the subroutine will just put them all together. So it's a very interesting idea. But sadly, this is such a complicated idea. I think we'll have to save this for next time. And then when this is done, we'll get back to our examples. And then we will go and look at our first assignments where we're going to take some relatively simple VBA programs and run them based on what we've been doing up to this point. Okay, namely interest rates. So this way we'll get used to it in stages, this VBA, and then we'll move on to the our discussion about derivatives, namely forwards and futures, and then finally we'll talk about options pretty much for the rest of the course. So we have a lot to look forward to. So I'll see you all next time.